What is Ohm's Law? By KayScience.com. Here is a series circuit where the cell causes the current to flow around the circuit. As the electrons flow through the metal wire, they collide with the vibrating metal ions. So the electrons collide with the positive metal ions and are slowed down. The more collisions that take place, the more the electrons are slowed down. Therefore, the more energy needed to force through the electrons, the higher the resistance. Resistance can be calculated using the equation R equals V over I, or resistance equals potential difference over current. It's question time. Attempt these questions to check your understanding. A resistor has this symbol, and a fixed resistor limits the current in a circuit. That is the job of a resistor, and this is what a resistor looks like in real life. In fixed resistors, the resistance does not change, whereas in variable resistors, which has this symbol, the resistance can be changed. The current can be changed by varying the resistance. It's question time. Attempt these questions to check your understanding. We're going to use this circuit to investigate how the current in a wire depends on the potential difference across that wire. This is a series circuit containing a DC power supply, an ammeter, a resistor, and a voltmeter connected in parallel across the resistor. We're going to use this circuit to investigate what is Ohm's law by changing the potential difference and then measuring the potential difference in current using the voltmeter and ammeter, and then plotting the data in this graph, where potential difference is on the x-axis and current is on the y-axis. When the potential difference is 0 volts, the current is 0 amps. When we increase the potential difference to 1 volt, the ammeter then reads 0.2 amps for this resistor. We then plot these two data points in the graph. And if we increase the potential difference to 2 volts, the ammeter then reads 0.4 amps. We then plot this data in the graph where 2 volts equals 0.4 amps. In this experiment, to investigate what is Ohm's law, each time we're increasing the potential difference by 1. So now 3 volts is going to equal 0.6 amps. We then plot this data in the graph. We then increase the potential difference by 1 to 4 volts, where the current will read 0.8 amps. And again, we plot this data in the graph. I hope you're starting to see a pattern here where every time we increase the potential difference by 1 volt, the current increases by 0.2 amps. We then continue collecting data, which then looks something like this in the graph. We have drawn a line of best fit going through the origin. The graph shows us how current is directly proportional to the potential difference. Every time the potential difference is increased by 1 volt, the current increases by 0.2 amps. Because the potential difference is directly proportional with the current, this means the resistance is constant throughout. So whichever measurements we use, the resistance will always be the same. We can show this using R equals V over I. So for example, at 2 volts, the ammeter reading was 0.4 amps. And we can calculate the resistance at this point by using the equation R equals V over I. So if we input this data into the equation, R equals 2 volts divided by 0.4 amps, where R equals 5 ohms. To show resistance is constant and does not change, we then calculate the resistance at a different point in the graph. For example, at 6 volts, the current was 1.2 amps. We input this data into the equation where R equals 6 volts divided by 1.2 amps. So R equals 5 ohms. So this graph shows us how current is directly proportional to the potential difference, as V and I increase at the same rate. As R equals V over I, this shows resistance is constant even as V and I change. This explains what Ohm's law is, which is where the current is directly proportional to the potential difference through a resistor at a constant temperature. It's question time. Attempt these questions to check your understanding. Here I'm drawing a graph which is a current potential difference graph, and the data shows how the current is directly proportional to the potential difference. Straight away, we know this shows Ohm's law. Ohm's law can be defined as the current through a resistor at a constant temperature is directly proportional to the potential difference across the resistor. So in the resistor, the temperature does not change. That's very important about Ohm's law. The temperature remains constant and does not change. So resistors are ohmic conductors. If the resistance stays constant as the current changes, as long as the temperature is constant. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.